Hi everyone, and welcome back to Maths and Physics with Mr. Simons. We make maths and physics easy and get you exam ready. Today's lesson on classwork, inequalities. Now we're solving linear inequalities, right? Same like we solve linear equations, now we're going to solve linear inequalities. So the previous lesson you need to know, which is also variation 8, that is how to represent linear inequalities. Now we're solving it, and then afterwards you can test if you can represent it. Right, so solve for x. And they given me minus 5 there, 13. So this reads 3x plus 1 is less than 13 or greater than equal to negative 5. So I'm throwing you somewhere in the deep end from the start. We're solving for x. So I want x on its own in the middle. So first, get rid of plus 1. Right, so if I take plus 1 across the inequality sign, it becomes minus 1. But what I do on this side, I must also do on the other side. So there, minus 5, minus 1. So I hope you can see that brown one became minus 1 and minus 1 on both sides. So now I'm left with 3x in the middle. Now 3x means 3 times x. Right, so how do I get rid of multiplication? I use division. So minus 5 minus 1 is minus 6 divided by 3. 13 minus 1 gives me 12 divided by 3. So now I'm left with x in the middle. 12 divided by 3 would give me 4. Minus 6 divided by 3 would give me negative 2. So my answer reads as follows. X is less than 4. So remember, the biggest value always points to the smaller item. That's why that reads x less than 4, x greater or equal to negative 2. Right? Now you see here we say illustrate your answer on a number line. So minus 2 is included because it's equal, but 4 is not. So what this means is minus 2 I have a solid closed dot or closed circle, and at 4 I have a open circle. So there are 2 closed circle, open circle, right? Right, they haven't specified anything, so then we naturally assume we're dealing with real numbers. Therefore, I've joined the line from minus 2 till 4. Right? Let's look at the second problem. Given 3 minus 4x greater or equal to x plus 5 and x element of real numbers. Alright? So again, my objective is I want all my x's on the same side. Right, so if I take negative 4 over, it becomes plus 4x. If I take plus 5 over, it becomes negative 5. X plus 4x would give me 5x. 3 minus 5 would give me negative 2. We always divide by whatever's in front of x, or the coefficient of x. So 5x divided by 5 would give me x. And then what I do on one side, I must do on the other side, minus 2 divided by 5. So this here basically reads x is less than. So minus 2 over 5 greater or equal to x. So I can read x less or equal to minus 2 over 5. Right, and then for extra mark or sometimes 2 marks in exam, we would say write the solution in interval notation or on a number line or in set builder notation. So in interval notation, less than, meaning it's less than and equal, so close parenthesis, right, square bracket. So minus 2 over 5 is where I'm starting, but if I become less and continue in that vein, I would eventually end up by negative infinity, which we're not sure where it is, but end up by negative infinity, and because we don't know where that ends, it is an open bracket whenever I use infinity. All right, so therefore interval notation, negative 2 over 5 to negative infinity. Right, next problem. All right, number 3, again solve for x. Now we've given you 3 in brackets minus 2x plus 4 minus x greater or equal to 2 in brackets times x minus 4 minus 16. And very important, they say x element of integers. Right? So there we're first testing distributive law. So there I must multiply 3 with everything in the bracket and 2 with everything in the bracket. So 3 times minus 2x gives me minus 6x. 3 times 4 would give me positive 12. Minus x stays minus x. 2 times x gives me 2x. 2 times negative 4 gives me negative 8 minus 16. Alright? So minus 6x minus x, or minus 1x minus 6x gives me minus 7x. Take all my x's to the same side. So if I take 2x across, positive 2x then becomes minus 2x. There I have minus 8 minus the 16, which gives me minus 24. If I take positive 12 across, it becomes negative 12. Right? So always remember, when we take something across the equal or inequality sign, it must change its sign. So minus 7 minus 2 gives me minus 9x. Minus 24 minus 12 gives me minus 36. Right, I want x on its own, so we will always divide by whatever's in front of x, which in this case happens to be minus 9. So minus 9x divided by negative 9, negative 36 divided by negative 9. Whatever I do on one side, I must do on the other side, right? So greater than, when I divide or multiply by a negative, the inequality sign must change direction. So that read minus 9x greater or equal to minus 36. Now it reads minus 9x less or equal to minus 36 over 9. So x, negative 9 and negative 9 cancel, so I'm left with x. Minus 36 divided by negative 9 gives me 4. Right, so if you don't remember that we change sign when we divide or multiply by a negative, then from here onwards your sum would be incorrect. Right, now we say write the solution in interval notation. So I'm starting by 4, it's included, it's equal, so therefore close parenthesis. And it goes from 4 all the way down to the negative values to negative infinity, which will always be with an open bracket, right? So that there is an interval notation. Right, let's go look at the fourth problem. Right, solve for x. So given to us 3 times x minus 1 over 4 less than 3x minus 4x plus 4 over 16. Alright, so my lowest common denominator, meaning the denominators at the bottom here, 16, or I must mark as one person has commented, lowest common multiple. So the reason why it says that, if we work with multiples of 4, it's 4, 8, 12, 16. So you see 4 and 16, the lowest common multiple between the two is 16. Right? So in short, 4 can go into 16. So now I'm doing an extra step to show you where the 16 comes in. So I'm going to multiply everything by 16. So you see there 3 times x would give me 3x, 3 times minus 1, negative 3. But I'm multiplying it by 16 over 4. 3x times the same 16. And there's 16 times 4x plus 4 in brackets over 16. So 4 goes in 16, 4 times. So I have 4 times 3x minus 3. 3 times 16 gives me 48, so that becomes 48x. 16 and 16 cancels there, so I'm left with minus 4x plus 4. 4 times 3x gives me 12x. 4 times negative 3 gives me negative 12. 48x minus 4x gives me 44x, and there, negative 4. Take all my x's to the same side, so 12x minus 44x. If I bring negative 12 across, it becomes positive 12, so minus 4 plus 12. 12 minus 44x gives me negative 32x, less than 8, right? Now we always divide by whatever's in front of x because we're solving for x, right? So therefore, minus 32x divided by negative 32 gives me x. But what I do on this side, division-wise, I must do on the other side as well. So 8 divided by negative 32. Right? I divided by a negative, so what happens to the inequality sign? It must change direction. Right? So now it reads x greater than instead of x less than. 8 over negative 32, 8 goes in itself once, 8 goes in 32 4 times. So therefore, x greater than negative 1 over 4. Says illustrate your answer on a number line if x is an element of whole numbers. No? So all numbers start from 0 and go on. It includes no rational numbers or fractions. Right? So therefore, x greater than negative 1 over 4. Right? Can't start by the negative. I start by 0, 1, 2, 3, 4. And it will continue in that vein. Right? So I hope you follow. I hope it gives you a clear indication. It's much just different ways to test inequalities and whether you can represent it and so on. All right. Now, the next lesson, we're going to look at simultaneous equations. So we're going to learn simultaneous equations via elimination. And then we have to learn how to do it via substitution, as well as using graphical ways to solve it. Right? So I wish you nothing but the best. Continue practicing. God bless. Bye.